Welcome to Earth Science. Let's talk about the superstorm of 1993, what was called the storm of the century. When I happen to be, as you are, a sophomore in high school. Pretty big storm, significant death impact from it, and a multifaceted storm. It wasn't just a snowstorm, there was a lot going on. It all revolved around a very, very, very strong mid latitude cyclone. So maybe not a bad idea right now to grab your diagram of the mid latitude cyclone. It's going to come up, as well as the drawings you did for the cold fronts and warm fronts. That cheat sheet is going to get you through this video, through the lab. The video and the cheat sheet will get you through the lab. I suppose that's what I should say. All right. I also went through and took a ton out of this, and I'm going to do a lot of it with you. Part one I just chucked entirely. So here we go with part two. Part one was just plotting the way that this low pressure center traveled up the coasts. I think we can get away without it this year. Let's just simplify and go right when it was at its strongest. Here's the low pressure center. That kind of looks like an L. There's the low pressure center. Let's superimpose on there a mid latitude cyclone, which you can do by following all these instructions, but let's just do it together in a video and call this thing good. All right, so here we go. This was the place where the storm was the strongest. And the mid-latitude cyclone, these things they spin around the low in the counterclockwise direction, right? So yes, I'm drawing this one a little more forward of where the one in your cheat sheet is, but that's because the storm had progressed a little bit more by this point. So let's go ahead and grab blue, draw a cold front right through there. Those should be triangles close enough to perfect. We'll be good. Okay? Behind this low, this very strong low, it really very powerfully sucked down cold, dry air out of Canada and slammed it at this coast of Florida. What we'll want to do, what we'll want to know is, what does that look like? Fortunately, you have a cheat sheet that looks exactly like this. What happens as that cold air comes in? There's the cold front on the map. Can you draw what you have on your cheat sheet here? I know mine is blank, but yours isn't. Can you draw and tell me how that cold front would have created storms in Florida? Sometimes there's a thing called a squall line, which goes right along with the cold fronts because the cold fronts are the things that create these very large storms. So like right along this, we could do that in purple with dashes. That's going to be like the place where the storms got serious. So this thing slammed into Florida. It spawned tornadoes. There was a very strong, even straight line winds were very, very strong. And it created storm surge, shoving water up onto this coast, which you are going to explain to me using your cheat sheet right here. Same time, as mid-latitude cyclones do, there's a warm front. There's cold air coming down from Canada. There's also warm air coming up from the south. Warm, wet air. And as we discussed on the cheat sheet, this pulls air up out of the south. It's warm, it's humid, and what I can't draw on paper is the fact that right here, it lifts up off the map, comes up into the air, continues to suck around in a counterclockwise way, and was responsible for dumping a whole bunch of snow up here through the Appalachian Mountains. That's that mountain chain that runs right up to the East Coast right here. It may sound weird to say that a warm front is the thing that caused a giant snowstorm, but it's true. This warm air being pulled up, rising up through the atmosphere, rising up over those mountains, cooling down, dumped a lot of snow, a snow that was a difficult amount to handle for the Appalachian Mountain chain. You are going to say how that happened. There's your warm fronts. Fortunately, once again, you've got a cheat sheet diagram that will take you right through this. How did this warm front create snow in the Appalachian Mountains? The warm air is coming in like this, off the ocean, it rises and gets up there in the mountains. Copy your notes, it's going to be fine. Don't panic. Okay? Let's do, I don't know, black. For a couple of other wind directions, just to say that the circulation around this low will continue to be counterclockwise. That's why that all this moisture was able to, oops, that one's accidental. All this moisture from down here was able to be carried up into the mountains. And then I'm thinking, we could probably call it good. And maybe we should add that this is CP, continental polar air being pulled down from Canada. And this is MT, maritime tropical air being pulled up from the Southern Oceans, Gulf of Mexico, etc. There you go. We did all that stuff, right? Nailed it. You give me why storm surge works, explain it a little bit. You can use the diagram, do it infographic style, draw and write if you want. Do those right off your notes. And then we're ready for part 3. I'm just going to keep on going. I'll send timestamps on this. So if you want to stop this video now and do all that, I'll do a timestamp to take you right to part 3. Welcome to part 3. Normally I have students draw these ISO lines. We haven't drawn ISO lines yet. We're going to do that the last week of the marking period. So I drew them for you. There you go. They're on there. All you're going to do, I got it super easy. Pick 3 colors and color in, say you pick purple, color in the above 30 inches of snow purple. 30 inches of snow is a lot for West Virginia. 30 inches of snow is a lot for Pulaski. And we've got plows and infrastructure and we're prepared to deal with major snowstorms. Not so much down there. And not for any reason other than it doesn't happen all that much, right? It wouldn't be practical to spend your money on a significant amount of snow removal infrastructure. So yeah, do that. That's going to basically show where this snowstorm was nailed as a result of this mid-latitude cyclone right here. You can do it. Good job. Pick 3 colors, fill those 3 zones in, easy peasy. What geographic feature looks like it may have contributed to the snowfall? What mountain chain did I already say is right through there? It's the Appalachians. You might have to look up how to spell it. It's a tricky word to spell. Once this storm, all right, that's it. Welcome to part 4 now. I'll pause again, do that. Welcome to part 4. Once the storm moved through, everybody says, oh, the superstorm of 1993 is over. Then upstate New York got a lake effect snow event on top of that. So we had a snowstorm fall on top of a snowstorm. Isn't that lovely? And it's because there's counterclockwise flow around a low, because this air got pulled over Lake Ontario, and Lake Ontario then, that moisture turns into lake effect snow, as we've kind of gotten used to being residents of Pulaski. So what I'd like you to do is you can use this diagram right here. You don't have to do the whole thing, but think about it. Why is it so snowy on the Tug Hill? If you had to create this little box to show somebody, hello, I just moved to Pulaski, what's it like here? You're going to say, lake effect snow is a thing, and here's why. That the air does this, it does this, and we get clouds and snow. Can you do that? That will do it all for part 4. And then congratulations, you made it. Which front was responsible for the tornadoes and thunderstorms? Which front was responsible for the snowstorm? If you forgot, you already did that right up here. And we already described that right up here. Then, choose one of the following 3 questions. Again, I really tried to minimize this lab to make it quick. I'm trying to do it 1 period, maybe into 2. Pick one of those 3 and answer them. Which one is the easiest for you to answer? Give me a sentence or 2, and we will be good. Good job, folks. Another lab down. Keep up the good work.